Good morning, sophomores. Here we are learning a little bit about human demographics. So, human population growth has gone kind of crazy over the past 500 years. As a species, you can say we have been extremely successful. Today, we're going to talk about why and talk about what effect that could potentially have on our ecosystem as a whole. Remember, in our last unit, we talked about the different aspects of planet Earth, the biosphere, hydrosphere, geosphere, and atmosphere. And hopefully you continue to think about how we as humans and all living things are continuing to impact these different parts of planet Earth. So you can see on my screen here, this is a really interesting website called worldometers.info. And this just happens to show an estimated model. Of course, it's not completely real, but based on worldwide birth and death rates, the potential for human population growth on planet Earth. So I'm just going to call it right there at that 930. So I'm going to just write down this number behind me on the board. And before we're done with our notes for today, we'll double check and see how many people potentially could have been added to our human worldwide population just in the time that we've been talking through this. Okay, so we're at 7,898,000,000. We'll just go 890,000, so it's nice and even. Right now it is about 11:17 a.m. when I'm recording this for you guys, so we will come back in a little bit and see how this turns out. Okay, so you should have your notes out for section 5.3 in your notes. We're talking about human population growth, and we're going to talk about why some countries have a really rapid rate of growth and while others have almost no growth or are actually experiencing a loss of their human populations. And it's probably not for the reasons that you might think. So the size of the human population has increased over time. Like all species, we have started with a very, very low number. There were actually multiple different types of, in our genus, multiple types of Homo species at the same time. We are Homo sapiens, of course. There were Homo erectus, Homo neanderthalensis. Our species just happens to be the one that outcompeted the rest. About 15 or 20,000 years ago, we were the only remaining species within our genus. So from that about 15 or 20,000 years ago to about 500 years ago, the human population, that of Homo sapiens, remained pretty low, around less than a million, maybe 500,000 worldwide. And that was probably because of disease and because of the limitations of food supply. But about 500 years ago, humans started to figure out how to mass produce food, and we figured out how to stop the spread of disease for the most part. And so now, starting about 500 years ago, the human population began to grow very, very rapidly. Your book has lots of graphs and charts in this chapter, and they're really, really interesting to dig in and to practice our chart reading skills. So here we can see from about 4000 BC, so that would be about 6,000 years ago since we're in 2020. The human population was about 7 million. And then we creeped up to almost 500,000,000. And then we had the Black Death that knocked the human population back down again. But again, around the 1500s, when we first figured out that we need to keep the water we drink separate from wastewater, and what the cause of most common diseases was, and how to mass produce food through the science of agriculture. Our population now in 2000 was 6.1 billion, and this estimation by 2075 is 9.2 billion. I'm not sure how accurate that is anymore. Some of these graphs are older than others. One of the most interesting people that your book talks about in this unit wasn't a scientist at all. He was actually an economist, so he dealt with money, helping bankers and governments and other people prepare for the future. And he was alive in the early 1900s. And at this point, the Industrial Revolution was just starting to take off. And he was concerned that the economy of Great Britain would not be able to survive the human population boom that he anticipated was coming. And he thought if the human population continued to grow unchecked, that there would be some limiting factors. We've talked about limiting factors in natural populations. Humans are not exempt from these. And he hypothesized that the limiting factors for humans would be war, famine, and disease. So I would dare to say he was right. We have wars going on all the time over finite resources like water and space and food. We have famine. There are millions of people on this planet that don't have enough to eat. And we have been in the midst of this global pandemic now for about 2 years. So diseases, whether they be viral, bacterial, or otherwise, spread much more rapidly in dense populations. So I would claim to say that he was correct. However, the peak of human population growth was really around the 1950s or 1960s. Since then, we are still increasing, but the rate of increase, if we were in math, we'd call that the slope of the line. The slope is just starting to tip oh so slightly, so it's not so straight up. It's subtle and it's difficult to see in some of our graphs, but try to look the next time we see human population graph, what happens around 1960, 1955, 1960. So the whole point of this section is to study human populations, and keep in mind that like every other population, we have to think about birth rates, death rates, and our age structure. And every different population or every different country has a different rate of growth that depends on the culture of that area and also birth rates, death rates, immigration, and emigration, just like any other natural population. So human population growth is a little bit more complicated because as humans, we might have cultural, religious, or even like we have reasons for why we do or do not choose to reproduce. We are not just driven by instincts. We have logic and reasoning and other things that drive our population growth. Nonetheless, we can look at different populations and kind of understand where they're at in what we call the demographic transition. According to demographers, some countries have very high birth rates, but oftentimes this is accompanied by very high death rates. These are what we may consider like a third world country where they may not have enough resources to sustain every single human in that population. Then we have countries that are in transition. They're still growing, but their birth rate is still high, but the death rate has started to decrease. These countries might have a little bit better quality of living for their population. They might have a government that works for them and that provides healthcare and education. But the ideal population will have zero population growth. ZPG is what they sometimes call it. And in this, we have low birth rates and low death rates. And again, that's difficult to say because many cultures worldwide really value large families and value children, and that's great. But from a demographer's perspective, a stable, healthy ecosystem, as far as humans is concerned, will have zero population growth. We'll have low birth rates, low death rates. People live long, healthy lives, have many resources to go around, and a very stable and functioning government. So all of these things start with birth and death rates, but it also deals with the quality of life, education, economic stability, access to health care. All of these things really are linked to this idea of the demographic transition. A model that we'll spend a lot of time with in this unit is called an age structure diagram. Let's look at a couple. Oh, here's the demographic transition before we get into those age structure diagrams. So stage one, we would consider like a first world country, or a third world country rather. So birth rate and death rate are very high. We may not have a lot of population growth. We could have a lot of population growth. It just kind of depends on what types of resources are available. In stage two, as education and healthcare increase, the death rate begins to fall. So a lot of countries in stage two are rapidly increasing. And then by stage three, birth rates will fall, and eventually we reach the ZPG so that people have smaller families, but all of those babies are expected to survive. I would say in the United States, we're somewhere between stage 2 and stage 3. Our population is a little bit more complicated because we do have a lot of immigration that occurs, and that's good for our economy. That's good for but our population grows a little bit faster, and that's not always just because of births. So at this ZPG area is kind of where demographers say that the economy is the most stable and that people have the highest quality of life. Okay, so here we have population growth in Niger, which is a country in Africa. And you can see here that they have a lot of kids at the bottom of this diagram. So lots and lots of little kids. This age group 10 to 14, which you guys are right on the edge of that age group, is right before the reproductive age group. Within 10 years, a lot of those individuals will be parents, and they will be contributing to the population, maybe. So you can see that there's a huge proportion below this line in Niger. In the United States, it's a little bit more narrow, which is interesting. Still a pretty good portion of the population, but not as wide. If you look at the bottom, this is 20%. Oh, but look at the scale. They changed the scale on us. And this is only about 6% of our population are males 0 to 4, and it's about even, about 6% are females 0 to 4. Whereas in this first one, it's almost 20%. So that's almost half of our population is from 0 to 4. And then in Japan, they have a very small proportion, only about 5% are males and 5% females. So less than 10% of their population is in that 0 to 4 range. And that's about the same in that 10 to 14. So we would say that this diagram in Japan is showing negative growth. Their population is actually decreasing. In the United States, we have slow growth, or it's pretty close to being 0 ZPG. But in Niger and in many other third world countries, we see rapid population growth. But if you notice, very few people live into their 50s, 60s, and beyond. Whereas in Japan and the United States, we still have a proportion of our population living into their 80s and 90s. So it's not just about births, it's about quality of life, it's about how long people expect to live. So the future human population is very unpredictable. Current predictions show that we will probably grow. Currently, your book said it was 7.6. That website said it was close to 7.9, which is interesting. By 2050, we estimate we'll have about 9 billion people. And this could potentially put a large strain on the environment and the global economy as well, because remember, those things go hand in hand. Okay, so that wraps up our notes for section 5.3. The human population has increased substantially over time. Although we are still growing, we're not growing as quickly. And we use age structure diagrams to see the percent of each age group that constitutes a population. And the most stable ecosystem and environment for humans will be where we have 0 population growth. If our human population continues to increase, we'll have new ecological problems that we will have to solve.